in ionic and covalent bonds. Covalent bonds are between a metal and a nonmetal, or a cation and an anion. Covalent bonds are between two nonmetals or two anions. Okay? Covalent bonds are sharing electrons, whereas in ionic bonds, there is a transfer of electrons from a cation to an anion. So then the cation no longer has its straggler electron, it has given it to an anion. Okay, covalent bonds, the electrons are, say, in, well, chlorine and oxygen. Okay, we're just going to go ahead and say that these two have started to bond together. There is going to be an electron cloud between both of these. Okay, and the electrons here are going to go back and forth between these elements, but it is going to spend most of its time in between both of the elements, or the atoms. Why? Because right here there's a strong pull for the electron to be, the shared electrons. Alright, now, naming. Alright, you need to be able to distinguish an ionic from a covalent bond. Well, you see two nonmetals, it is a covalent bond. Alright, so the first rule of naming an ionic bond, okay, right up here, top left corner, the first element in the formula name is named first using the normal name of the element. So if we have oxygen, it is going to be oxygen. Okay. If we have fluorine, it is going to be fluorine. All right. Now, if we have here, the second element, okay, so we have CO2. Yes, it's carbon dioxide. All right, I just gave you the name for it. Well, the second element name is named as if it were an anion. We've already determined that anions end with IDE. Okay, IDE. So there are no ions in these compounds, but we use IDE ending on the second element as if it were an anion. Don't get boggled down in that. All right. IDE is the ending. Okay. Greek prefixes, shown in this table below right here, are used for each element to indicate the number of the atoms of that element present in the compound. So notice, there's a 1 here and a 2 here. We need to go to rule number 4 first before we proceed. Okay. Greek prefixes, right, or the prefix mono, which is 1, is never used for naming the first element. Okay, so our book gives an example. There's a difference between these two elements. You can see there's 2 oxygens here as opposed to 1 up here. For both of these, they're going to start the exact same because there's 1 carbon. Okay, so it's carbon and carbon. But now we know there's 1 oxygen here. Well, down below we have 2 oxygen. Now we need to add the mono. Monoxide versus dioxide. Right? So you are just adding Greek prefixes to the anion name. Now, here's the difference. Say we have we have a gas. We have 2 carbon and 4 hydrogen. All right? Here's where we need to add a root to the first element. Well, we have 2 right there. We've got 2 right there, so we're going to name that di. Keep the original element's name. So dicarbon. We have 4 hydrogen, so we look up here, we got 4, okay, tetra, hydride, excuse me. right? Dicarbon tetrahydride. All right, so for the last little bit, I want you to be able to write these, predict the products, and I would also like you to be able to balance these. So let's take a look. When we're writing, okay, we see that for the first equation we have iron. Right, we're writing for the reactant side. Reactant side is everything on the left side of the arrow, and then products is going to be on the right side of the arrow. Remember that this sign means reacts with. The arrow is yields or produces. And the plus sign on the product side of the equation means and. Okay. Now that you know all that, let's go ahead and try and write out predicting our equation, okay, predicting what we know about iron and copper, which are transition metals on the periodic table, which usually or oftentimes means they're a variable charge element. Write out the word equation and predict the products. Okay, so we have iron 2 reacts with copper 2 sulfate. Excuse me, that's a U. To produce iron 2 sulfate and copper 2. Wow. All right. So we've predicted that this is a single replacement reaction, right? We have A, B plus C going to produce A plus CB. Okay. Now let's take a look. You might ask why I am predicting or how I found out that iron 2, copper 2, how do I know that? This is all based off of sulfate. Okay, so if we look at a plus 2 charge, minus 2 charge, this should make sense, right? So now we have copper alone. And now when we bind iron and sulfate together, right? Go to your ionic bonding. We put those together. We have Fe2SO4 2. Well, 2 and 2 reduce to 1 and 1. The same thing, okay? So eventually this turns out to be FeSO4. Okay, so iron sulfate. Right, plus iron sulfate. Right? This right here, this reduction right here has happened in copper sulfate. Okay? So, I'm going to clear some of this junk out for you. Right? We have our chemical equation both in words and we've used the elemental symbols to find out exactly what we need to know. We've got the charges, we've got it written, we know that it's a single reaction. Well, now it's time to actually balance this bad boy. So, how do we do that? Well, you can do it the way I taught you in class with drawing a diagram. Or, if you can do it in your head, be my guest. This one is really, really nice to balance. Okay, I have iron, copper, and sulfate. Iron, copper, and sulfate. How many irons do I have on the reactant side? 1. Copper, 1. Sulfate, 1. Well, iron on this side, I have 1. Copper, I only have 1. Sulfate, I only have 1. It's balanced. You're welcome. Okay. Now go ahead and try and do the exact same thing. Word equation, write it out, predicting the products, and then balance it on your own. So now that you've guessed, let's take a look. You have sodium fluoride reacts with hydrochloric acid, or, using your covalent bonding rules, hydrogen monochloride to produce sodium chloride and hydrogen monofluoride. That looks like. And it's already balanced once again. Go ahead and balance the equations and predict the products, please. Alright, so aluminum has a +3 charge, oxygen has a -2 charge. We're going to put that together to make aluminum oxide. Remember, we're just crisscrossing method these. Alright, so let's go ahead and let's start with oxygen on this one. We have 2 and 3. Well, if you multiply 2 times 3, that's 6. So let's go ahead and make 6 oxygen on each side. Therefore, I'm going to go with 2. 3, we have 6 oxygen, so those cancel out. Now we obviously have 1 oxygen over here, and 4, right? 2 times 2 is 4. So we need 4 aluminum. Simple, that aluminum standing alone, put a 4 coefficient in front of it, and you're all balanced. We've got a single replacement reaction with 2 cations. So we have sodium chloride reacts with aluminum to produce sodium and aluminum chloride. Well, now we have 1 aluminum, or excuse me, 1 sodium, 1 sodium. We have 1 chlorine, 3 chlorine. So how do we remedy that? Put a 3 in front of sodium chloride. But now we have just changed our sodium from 1 to 3 on our reactant side. Move to the products. Now we're good. We have 3 sodium, 3 sodium, 3 chlorine, 3 chlorine. Our aluminums, we don't have to adjust at all. You're balanced. Last but not least, another single replacement reaction with a polyatomic ion that we're going to have to balance. So aluminum sulfate reacts with magnesium to produce aluminum and magnesium sulfate. Oh man, here we go. So aluminums. Well, let's start with aluminum sulfate. I have 2 aluminums. That's easily remedied. We're balanced on aluminum. We have 3 sulfate. Go ahead and put 3. We now have 3 sulfates. Well, now we have 3 magnesium. Put a 3 in front of that magnesium, and we're done. If you have any questions, please let me know. Come see me. Alright, we're coming down. Tuesday is the final day. Alright, so go ahead and, Tuesday is the 2RW final, and Thursday is the 3RW final, or 3W final. Come find me, ask me questions other than what's on the test, and no, I won't give you an A. Alright, keep up the good hard work. I appreciate all you've done, and good luck on your final.